Unlike many of my classmates, I have never really struggled with math anxiety. I've always kept a very positive disposition in math, and I've always remained very confident in my abilities. However, in high school, I noticed that all of a sudden my grades on my tests were dropping dramatically. And I would understand all the concepts in class, I'd be able to do the homework really easily, but then on tests, I would just bomb them almost every time. And my teacher noticed that in my work on my tests, I would be doing all of the procedures correctly, and um, all my work would be accurate, and then all of a sudden I would either just stop and circle whatever my answer was, or all of a sudden I would totally switch gears and do something completely different. And she noticed that while I was taking my tests, every time a different student shifted in their seat or got up to sharpen a pencil or something, I would look up. And whenever I would look up, all of a sudden, whatever train of thought I was on would get lost. And when I would look back at my paper, that distraction kind of hindered me from getting back on track. And that's when I would just derail. And so when she noticed that, she got me accommodations, and I was able to take my tests in a different classroom by myself in order to eliminate that barrier. And she was able to promote equity within her classroom by eliminating that barrier and ensuring that all of her students got what they needed to be successful. As I entered the classroom this semester, I was able to carry this mindset with me and this desire to promote an equitable environment for my students like it was provided for me. And I was able to use my experiences that I had in high school and my understanding of different educational theories in order to guide my instruction and help my students achieve conceptual understanding. One of the theorists I relied heavily upon was Vygotsky, specifically his zone of proximal development. In his zone of proximal development theory, he discusses how each student is different and they therefore need individualized instruction. This individualized instruction helps them achieve that conceptual understanding because we are able to meet them where they are and provide lessons that are tactile and manipulative in order to help overcome the barriers that they're facing. He also talks a lot about social learning theory, which is based upon the idea that students need to work cooperatively in order to construct understanding and in order to achieve a deeper understanding of new concepts. And this hinges a lot on communication and how students are able to work in small groups with one another in order to build on that learning and in order to be able to continue to explore in math. Piaget's constructivist theory also helped me as I planned my lessons, specifically in the connections in between lessons, because in his constructivist theory, he teaches us that we need to build upon prior knowledge and activate their schema, in which case the filing cabinets within their heads, they need to know where to file away this new information and be able to connect it to things they already know, so that way they're able to commit the new information to memory instead of letting it get lost with other things that aren't necessarily important to keep within our brains. The process standards also played a large role in my lesson planning. Communication and connections I already talked about, but problem solving, representation, and reasoning and proof also played a huge role in my lessons. One of the ways I used problem solving in one of my lessons was I made a puzzle, and each of the puzzle pieces was a triangle, and on the sides of the triangle they had different problems that, like addition and subtraction problems of fractions, or there was an answer, and the triangle that had an answer corresponded with a problem, and in order to complete the puzzle you had to have the correct problems matched with their answers in order to create the full puzzle. And the problem solving was really layered because on one hand the students were trying to solve the problems that were on each side, but they were also trying to solve the puzzle as a whole. And reasoning and proof also played a large part in this specific lesson because the students were required to prove their answers and the accuracy to one another in order to create the puzzle. And then also there were two different equations that actually had the same answer, and so there were a couple pieces that could have matched up with in different places, but if you matched them with the wrong one, then it wouldn't have completed the puzzle. And so students were required to reason through that and try to figure out how to put the puzzle together. Another way that I used representation was through our anchor charts and through manipulatives. Manipulatives are very, very important for students, and as a special education major, I'm very used to incorporating manipulatives into my lessons. I really think that it's important that students have a tactile way to experience the lesson in order to fully grasp it and in order to better demonstrate their understanding of the math. And so for me, this meant more than just having a game or some way that they can plot a point on a grid, but they needed to be able to move that point on the grid and be able to experience how the x-axis affects the y-axis and things like that. So manipulatives was one of the things that I was really good at because I'm very comfortable with manipulatives. However, uh, my anchor charts that were my models and stuff, those were definitely a little more difficult for me to do because I'm less used to making anchor charts and making them visually appealing to students. Something else we worked on a lot in this class was the assessments. And over the course of the semester, I realized I needed to make a switch from assessing isolated indicators to assessing isolated skills. An example of an indicator would be if a student missed a question number 4 on a worksheet. And if question number 4 was an addition problem, the assumption is they're struggling with addition. However, with assessing isolated skills, you're able to look at the work and see where it was that in the process that they were messing up and what it was they were struggling with. Whether they were messing up with keeping the tens place in the addition as they went through the process, or was it something because they accidentally subtracted, and is it the symbol that they're not understanding? Once I made that switch over to assessing isolated skills, it made it a lot easier for me to inform my practice as I was doing my lesson because I was able to see where it was the students were struggling. For example, one of my students was really struggling with remembering to flip the fraction whenever she was doing that process. And so I was able to realize that and remind her, and so that way she was able to complete the process and get the information to stick within her brain. As I move forward, I do realize I need to be better at my anchor charts, making them more visually appealing to students, and also having them more organized and colorful, because I do realize that students need to be visually engaged, especially during the direct instruction portion of the lesson. However, my main goal as I continue on as an educator is to maintain a growth mindset in myself and continue to learn new mathematical principles and apply them to my practice, but also to encourage my kids to develop mathematical mindsets and growth mindsets so that they can overcome their struggles like I did. I want them to know that their disabilities and the disorders and the hurdles that they're facing in math doesn't have to be the end and that they can overcome them. And I want to be able to be the teacher who's able to provide those tools in order to overcome those hurdles.